Right. So, perhaps the first thing to be brought to your attention is the fact that you see the column names on the top of the dataset right away. There's nothing complicated hiding behind the curtains here. By default, Python assumes that row 1 from the CSV file you are importing contains column names and no data values. Then, from the top to the bottom row, you see the indices that set up the vertical organization of the information in the data frame. The indices start from 0 because in programming, we always begin counting from 0, not 1. So, index 0 indicates the first row of our table, index 1 the second row, and so on until index 699, which represents row number 700. Let's go back to the top of the table. Horizontally, we have columns with data, ID, reason for absence, date, etc., until absenteeism time in hours. Everything looks okay. So, what needs to be done in terms of pre-processing? Remember, it is essential to always eyeball your data first. This means you must carefully examine it from left to right and top to bottom. This is to check for errors which potentially indicate that, for example, you have imported the wrong file, or the company you have paid has not delivered the exact information you wanted. And yet here, while you are executing the first steps of pre-processing, comes a very important peculiarity about programming in Python. At the beginning of your code, you must always make a copy of your initial data set. Why is that necessary? Because otherwise, you start manipulating the data frame. The changes you make will be applied to your original data set. For example, renaming a column from raw data will not give you the chance to restore the previous column name if you have forgotten it. Hence, using a copy is playing on the safe side, making sure the initial data frame won't be modified, and you'll be able to refer to it at a later stage of the analysis if needed. This was the logic from a programming point of view, and now we'll show you how to do this in Python. To a new variable called df, which is the naming convention for data frames in Python, we will assign a copy of the initial data by typing raw csvdata.copy, open and close parentheses. And that's it. Did this work? Let's check the content of the variable df. Absolutely. We see an identical, unaltered data frame, which is an exact copy of the original raw CSV data. Perfect. Therefore, we are, so to speak, free to make any changes to df. And in case we make an incorrect manipulation, we can always go back to the initial dataset stored in the raw CSV data variable and start fresh. Now, let me share two interesting tricks with you. They will be very valuable throughout the case study we are solving together. Occasionally, your data will be so wide or long that Jupyter will not display it in its entirety. On the contrary, quite often, you will want all available values to be visible. As a consequence, you could apply the Pandas max columns and rows display options. The syntax goes like this: pd.options.display.maxColumns equals, and then you must insert the number of maximum columns you'd like to see. The code is analogical for the rows. You should just end it by stating max rows equals. Moreover, since we want to observe the entire data frame, instead of inserting an unnaturally large number as a maximum value, we are able to set both quantities to have no limit. This could be done by using the keyword none. Thus, Python will understand this command as set no maximum value. Okay, so by running these two lines of code, we have set the preferred display options. To see the data frame now, we need to execute display open parentheses df close parentheses. And here we go. We can see that no single row or column is missing. Fantastic! And if your data set is much larger than the one we have here, And you still need to check for missing values. What you can do is print a concise summary of the data frame. This can be done by applying the info method directly to DF. So, when we execute this cell, we will receive an output telling us the number of columns in our data, as well as their names and respective data types. Moreover, you see all columns contain precisely 700 values each, which is real proof there are no missing values in our table. Let's take a little break at this point. In the next video, we will quickly discuss a few concepts related to programming terminology. After we've done that, we will set off to interpreting the content of our data frame. Thanks for watching.